Hello and welcome to the section 10.3 lecture. Today we're going to talk about factoring out common factors. It's going to be the first day of a handful of days, I want to say 3, that are all about factoring polynomials. We're still talking about polynomials, so that part isn't going away, but specifically we're talking today about just factoring out common factors. So if you remember from yesterday, we talked about multiplying polynomials, where I would take this and I would say this is x times 5x plus x times 12. And when I simplify that, when I write that as cleanly as I can, I get this, 5x squared plus 12x. So factoring is going the opposite direction of multiplying. Okay, that's what it is. Factoring is the reverse process of multiplying. Okay. So in each one of these, I'm going to, at least in the first couple, I'm going to write out, kind of breaking it out into factors, and then showing what the common factor is between the two terms or the multiple terms, and how we pull that out in front. So our goal today is to start with something that doesn't have parentheses, and hopefully our final answer will include parentheses. So when I look at this, I notice that 15x, I can think of that as 3 times 5 times x. And then I can think of 10 as 2 times 5. And I notice that both of those have a factor or a piece that's being multiplied together of 5. And so I can pull that 5 out in front. And that's what I'm going to do to factor it out. I'm bringing it out of those two terms and bringing it in front and in front of parentheses. What am I left with in here? 3 and x. And then over here, I'm left with a 2. That has been factored. I have factored out a 5 out of that. Factored a 5 out of each term of that polynomial. Okay. On the next one, I might look at that as, I don't know, I'll be kind of technical here. -1 times 2 times 3 times x, and then over here I just have 3. 3 is a prime number. And I'm actually going to say 3 times 1, just to make the next step make a little bit of sense. So when I pull out what I can, when I factor out what I can, I notice that they both have 3's. And so I can bring a 3 out in front. If I bring a 3 out in front, what is this one left with? A -1, a 2, and 2 x's. Well, I don't want to write all that, so I'm going to write it simplified. And then what's this one left with? And that's a very important aspect of this problem, that it's left with a 1. Even though if I would have thought of it as just a 3, okay, that's a huge eraser. If I would have thought of it as just a 3, and I factored that 3 out, I get a lot of people confused about what is left there. They think, well, I took everything away from there. There's still a 1. I want you to remember that there's still a 1 that can be left over. Okay? But that is my final answer. That is completely factored. And I know that I'm done if the things that are left in the parentheses have no common factor remaining. In my next one, this is the last one that I'm going to do by breaking it down this way. Typically, I don't break it down into this much detail. And for good reason. A lot of times there's a lot of stuff going on. -21 n to the 5th feels like -1 times 3 times 7 and 5 n's. And then negative 14n cubed, I'm actually going to say that that's plus a negative 1 times a 2 times a 7 times 3n's. I barely fit that one in there. That's good. So what all is common in the two terms that I have? I have a negative 1. I have a negative 1 in both of them. I have a 7 in both of them.
Mr. Kemp, please call the athletic office. Mr. Kemp, please call the athletic office. 7159. Thanks.
That was going to be bad. So I have a negative 1, a 7, and 3 n's in both of them. So I'm going to bring all those out in front. A negative 1, a 7, and 3 n's. And what does that leave me with? If I want to, I can kind of think about crossing those out because I've taken those out of their respective terms and brought them in front of the parentheses. So over here, I'm left with a 3 and 2 n's. Well, that's 3n squared. Over here, I'm just left with a 2. Now, I do need to simplify what I have out in front, and I could have done that ahead of time. But I have negative 7n cubed times 3n squared plus 2. Okay. Now, as you get more and more practice with this, it's gonna turn out to be a little more obvious what your common factors are going to be, and you don't have to split it up as painstakingly as I have in those first three. So just looking at this one, number-wise, I'm thinking, okay, 2 times 3, 3 times 3, 9 times 3. So they all have 3's. And then variable-wise, variables are a little bit different. As we saw in this one here, it's more that I'm taking out the lowest exponent of variables that I have. So here I had n cubed and n to the 5th, and I took out 3 n's. In this one, I have a 3 p's, 2 p's, and 1 p. So I can take out 1 p. And then from here, kind of an easier way to think about moving on from here, once you figure out what you want to take out, you can almost think about dividing. 6p cubed divided by 3p. 6 divided by 3 is 2. P cubed divided by p is p squared. Negative 9p squared divided by 3p. 9 divided by 3, or negative 9 divided by 3 would be negative 3. P squared divided by p would be p. 27 divided by 3 would be 9, and p divided by p would be 1. And so that is completely factored. And that's a lot quicker and easier way to do it. Granted, it took a little bit of time, but I was talking through a lot of it. Sometimes, and I'm going to do this on purpose, so bear with me, sometimes we factor something out and we think that's all we can do. It's always a good idea to go back through and check that you didn't miss anything. But I know that 2, 3, and 9 don't have any common factors. Maybe I look at this one and I think, wow, those are all even numbers. I can factor a 2 out. I can't factor any r's out because this one doesn't have any r's. So maybe I just think, well, I can factor out a 2. 48 divided by 2 is 24. 42 divided by 2 is 21. 30 divided by 2 is 15. And 36 divided by 2 is... ouch. Now my head hurts. 13, not 13. Wow, brain fart. 15. I want to say, okay, 18. There we go. This one has an R on it. Sorry. It's been a long day. If you can tell what time it is, it's the end of the day right now, but I want to get this video made for us. Okay. And then, like I said, it's always a good idea to go back through and check and make sure that you took out the maximum that you could factor out. But then when I look at all these, I notice that they're all still multiples of 3. Okay, which means that I could have taken a 3 out in the beginning also. Really would have been like taking a 6 out from everything. So I'm saying that I can take out a 3, and 2 times 3 is 6. So I can take out an additional 3 from all these. And 24 divided by 3 is 8. 21 divided by 3 is 7. 15 divided by 3 is 5. And 18 divided by 3 is 6. Now I'm done. It's okay to do it in 2 steps. It's obviously less work if you can do it in 1. But if you don't see it right away, you don't see it right away, and that's okay. Do what you can and then reassess. Sorry. Let's try to get this one all in one go. This one's kind of meant to get us to see that we can actually do something a little bit tricky, but I'm not going to do that. I'm just going to live with it being, with one part of it being kind of ugly. I notice that number-wise, I have negative 18, 4, and negative 2. Those are all even. I can take out a 2. Actually, before I do that, let me assess the variables. I have an H, and 3 H's. So I can take out 1 H. I have a K, actually, okay, 2 K's, 2 K's, and 1 K. So I can take out a K. I have J's in these two, but I don't have a J in the first one, so I can't take any J's out. Okay. So now I have negative 18 divided by 2 is negative 9. I am taking that H out and one of the K's out, so all that's left here is a K. I'm taking 2 out of the 4, so that's now a 2. Taking the H out, taking one of the K's out, leaving all the J's, so K, J squared. And then I'm taking that 2 out, taking one of the H's out and one of the K's out, or the K. So I have H squared times J. And so that's all I can do. Now, I do want to throw one other possibility out there. If you don't like all the negatives in this part of the problem, you could take out, even though it's not common to all of them, you could take out a negative 2 HK, and then you'd have positive 9K minus, I need to switch this sign, minus 2K J squared, and plus H squared J. So taking out that negative just switches the signs of all the other ones. And that's totally valid. You can do that. There's no harm in it, but it's also not required. But if you would rather have a negative out here than 2 negatives inside, sometimes people would rather do that. Okay? But either way, that's totally fine. Go ahead and pause the video and try these 3. Hopefully you had a chance to do that, and you saw that this one was 4x squared that you got to factor out, because this leaves me with 8x to the third plus 7. There is no common factor between 8 and 7, and x cubed is in one of them, and there's no x's in the other one. Hopefully in the next one you saw that you should take out a negative, and it should be a negative 7 p to the fourth. Okay, I kind of think of this as trying to figure out the smallest piece that's in, or sorry, the biggest piece that's in every one of my terms. Okay, this would leave you with 10p cubed plus 7p squared. Yeah, that's a big jump, isn't it? No, sorry, not 7p squared, just 7p. That's where it is. And then minus 9, or sorry, plus 9. And then in the last one, you don't get to take any numbers out. You get to take out one x and one y. So inside I'm left with 2y minus x plus 2. Okay? That being said, if you have any questions, make sure they go on the left side of that vertical line. Get those questions answered by me. Otherwise, I hope you have a great day, and we will see you in class.